from Stanford University.
Good morning. I'm an ecologist and I study ants because I'm interested in systems that work without central control. Ants are a great example because ants always live in colonies consisting of a bunch of sterile female workers. Those are the ants you see walking around. And then one or more reproductive females that we call queens, but in fact they have no power or authority. All they do is lay the eggs. And in fact, in an ant colony, nobody gives instructions to anybody else. Nobody tells anybody what to do. And so ant colonies are an example of a system that's actually very common in nature. Another example is a brain. There's no neuron in your brain that tells another neuron to think about ants. There are also a lot of examples, as you know, of engineered data networks that work without central control. As they get larger, it's becoming clear that central control is expensive and may not be very effective. And of course, there are human organizations. An example is the open source community that work without central control. And all of these systems that work without central control use algorithms based on local interactions. So in ants, it's usually smell. An ant smells with its antennae. And when one ant touches another with its antennae, it can tell if the other ant is a nestmate or what task it's been doing. And what I study is the algorithms based on the rate of interaction that ants use to decide what to do. And that way, an ant is similar to a neuron that uses just the rate at which it meets other neurons to decide whether to fire. So I'm interested in the analogies between systems in these algorithms that regulate collective behavior. One analogy that we've looked at is one between desert ants working at very high operating costs use an algorithm that's similar to the one TCP/IP, the protocol used to regulate data traffic, which was also set up when the internet was very new. Operating costs were high, and it was important not to lose data. We call that analogy Anternet. So the main point that I really want to make is that in looking for analogies across systems in the algorithms that regulate collective behavior in systems without central control, that it's really important to think about ecology. Because where I think we're going to find interesting analogies is between systems that are solving similar ecological problems, whether those are problems of operating costs, of the distribution of resources, the threat of rupture, the threat of a security breach. And what we're going to see, I believe, is that when we look at different kinds of systems without central control, that we will see analogous algorithms using local interactions to regulate behavior in similar ecological situations. Thank you.